Welcome to Big Data on Little Linux. I'm going to go a little bit fast because I have a number of slides I want to get through. So I'm a HPC high performance computing admin at a genomics lab. We do operations, we don't shy away from it. We run applications that run on servers. Cloud is somebody else's server. We don't run on other people's servers. That's not us. And we are working to fight cancer. So, this is really cool. This is not something that we did. This is from open source, the Economist website. But you can see this is the kind of work that we do. We figure out treatments that will help people actually keep living. This is pretty cool stuff. That's not why you're here. You're here because I said I was going to talk about big data, and I've got some war stories, and I'm going to get to them. So, you can buy servers with a lot of RAM nowadays. And, if you've got a lot of RAM, just process your data in RAM. You don't need any special big data tools to do that, right? Well, you still have to get the data in and out of RAM. You still got to process it. You still got to store it. So what's your storage backend? How do you actually get the data onto your processing nodes? Do you use Windows file sharing? Do you use NFS, iSCSI? Once you've got the processing, how do you scale your processing? Do you use threads? Do you use distributed memory, shared memory? What kind of HPC tools do you use? In our case, we keep it pretty simple. Our data usually does fit into memory. The instruments will run. They'll generate data per run, 1 to 4 days, several terabytes of data. We have a lot of instruments, so we can generate a lot of data. Several terabytes a week adds up pretty quick. Per sample, our analysis scripts are pretty simple. We're not doing a whole lot of complex analysis on the compute side for big data. We're not using Hadoop or anything crazy. We're just running regular tools on large data sets. So we want to scale our computers. We want to buy computers with lots of cores, lots of memory. Let's just run samples faster, more samples per system. So to scale out, we just buy more servers. Pretty simple from the processing side. I'm going to talk to you about the storage side more than that. So for the storage side, again, fairly simple. You can buy expensive enterprise systems. And if you have the money, go ahead and do that. Buy your big Isilons, buy your big NetApps. Spend that money. Give EMC $1 million or two. If you want to save some money, in healthcare, we actually want to save some money. Can you imagine? Just run Linux. So how hard can it be? All right. So what's the worst thing any of you have ever seen a computer do? Catch fire? That's a pretty bad one. I've seen some bad things, people. All right. I lied to you. This talk is actually everything is broken and needs replaced, upgraded, or patched. I found the bug so you don't have to. So the hardware's broken. Pretty simple. You can swap out new hardware. Troubleshooting hardware is a little bit easier than troubleshooting software because it's physical. You can go and replace parts. You can see the parts. You can look at them. The biggest thing that fails is memory. And memory does fail. You will corrupt data. You will corrupt file systems. I've seen it. It's not theoretical. So definitely burn in your systems and buy supported systems. You don't just buy the first thing that comes off of the boat from Asia. If you do that, you'll have a lot of systems that are really cheap and you'll have a lot of failures. So spend the extra money. It's not that much more. Get some brand name components, get some vendor support, or enjoy dealing with tons of bad systems. Talk more about redundancy later. Okay, so you've got your HPC system set up. You're running NFS. Your users are happy. They're using their data. And all of a sudden you come in Monday morning, all the servers are off. Why are all the servers off? Because they all hit emergency shutdown at 105C. When you use the servers, they get hot. Solution number one, upgrade your firmware, upgrade your BIOS, turn on your fans. You've got servers, $5,000 worth of CPUs in a server. You're worried about $20 worth of fans? No. Turn your fans on 100%, run them all the time, get your fans going, cool your systems down. They'll run a lot faster. They might run twice as fast. This is a big deal. Your CPUs might be throttling, you don't even know it. You might run twice as fast just by turning on your fans. All right, so your systems aren't crashing anymore. Now you've got NFS going. Your users come to you. NFS is broken. What's broken? Is it the server? Is it the client? On Linux? Why not both? All right, so on Linux, the Linux NFS implementation, God bless them, but it's probably not the best implementation that has ever occurred in the state of, in the world for NFS implementations. The caching logic is complicated and confusing and probably broken. Linux will try to use one TCP connection for everything to everyone's detriment. The RPC system does not multiplex very well by default. And for no good reason, way back in the day, they said, we're going to put the Linux NFS server in the kernel. Why not? It's fast. But think about it. Do we do SSH in the kernel? No. Do we do HTTP in the kernel? No. Why are we doing NFS in the kernel? Really for no good reason. Pretty much they discovered this as soon as they did it, but it was too late. Plowed forward, and NFS is still in the kernel to this day. So, going to be fixed, but not yet. All right. But Linux NFS being horrible is not really the fault of the people working on Linux NFS. The problem here is that all software is broken. How do you fix software? You test it. You upgrade it. How do you test the kernel where NFS is? You don't. The Linux automated testing is essentially just, does it boot? All right, ship it out. See if anybody reports bugs. If nobody uses the software, if nobody's reporting bugs, the code is buggy. The code is buggy. Linux is surprisingly buggy. How hard is it to write C code? I mean, come on, people. No, obviously this is a joke. Yeah. C is not, writing C code is not actually simple to do bug-free. So I told you to buy hardware support, the next thing I'm going to tell you to do is buy software to support. Or if you don't buy software support, at least use the same stuff that people who are paying for software support are using. So that means in this case, run your Red Hat kernels, run your kernel.org long-term support kernels. Do not run Ubuntu stock kernels. Because they're full of bugs. So how does the Linux kernel manage memory? We're going to get back to NFS, but we're going to take a detour. How does the Linux kernel deal with memory? Well, not very well, it turns out. And this is a surprise to a lot of Linux kernel maintainers. What do you mean? I wrote all of this code to handle all of these out-of-memory conditions, and you're telling me it never actually gets run? Are you kidding me? No, Linux will hang forever if it gets into an in-kernel low-memory situation, and that's the best case. In the worst case, it runs out of memory, it corrupts your data. I've seen it happen. Linux will use all of its in-kernel memory, and that hits bugs because code's running over and over trying to allocate memory. It doesn't happen very often. Hits a bug, your data's corrupted. All right. So the reason NFS is actually broken is because you've run out of memory. And you'll see the symptoms of this if your server runs slowly for no reason. You're looking at top, it's not doing anything. Why is it running so slowly? You've got out-of-memory errors in the logs, but there's plenty of free memory. Maybe your file system's corrupt. What the heck happened? What happened is your 10 gig NIC ran your kernel out of memory. Combined with your XFS file system allocating tons of memory, your kernel ran out of memory. So give it more memory, upgrade your kernel, step one, and increase some tunables. Slides are on the web, so you can go look at these tunables later. All right. Now your system's a little bit more stable, but your users are still coming to you. NFS is still slow. NFS is still broken. Well, what's going on here? Well, you've got high load on the clients now. The server's doing okay, but the clients have high load and they're crashing. All right. So the issue here is all software is buggy. The NFS client software is buggy. There's a particular tunable that everybody knows to set, even though the documentation says you don't have to set it. When you don't set that tunable, then your graphs look kind of insane. You see the load is spiking up to 100 when the server is essentially idle. Set your tunable, your load doesn't spike anymore. Your servers don't crash anymore. All right, you have to set this tunable before the NFS mounts get mounted, so you got to put it in mod probe. And this is just 3 lines on one slide in this talk, but it's probably the most important 3 lines. Use multiple IPs on the server. If you've got a server and it's only got one IP, all of your connections from each client are going over one TCP connection, which is slow. It makes sense. Multiplex your connections. I don't know why the Linux client doesn't do this by default, but you can trick it into doing it. Just give your server a whole bunch of IPs and set up a whole bunch of directory mounts in your FS tab, and now you've got multiple IP connections to your server, and it will run a lot faster because you don't have people stepping all over each other. All right, so now your reads and writes are going mostly okay, but your users are still saying, well, heavy write loads cause issues. So what's happened here is, on the server side, you've filled up your whole server's memory. As much, you got a server with a huge amount of RAM, and Linux has filled it all up with dirty data, with data that needs to be written to disk. And at some point, Linux is going to say, hold on, this is too much data in memory. I need to start writing this to disk. And at that point, things become synchronous. They go really slowly, and if you're also doing reads at the same time, then things go really slowly. So tell Linux not to store so much memory in the page cache. And if you really care about latency, and I've done this, just sync constantly. I mean, why not? Just literally just sync all the time. And this does work. It slows everything down, but it works. All right. So now your users are coming and saying, well, all right, NFS is still acting weird. I don't know what's going on. I got these weird application errors. I can't figure it out. Well, so the users have tried to, got NFS. They're trying to, hammer this round peg in a square hole, use NFS for everything. We're going to just store everything in a file on NFS. So now, because of that, and because of NFS caching, your application has an invisible distributed cache on every single server that you can't query, control, and validate. You can't see. Bad idea. Fix that, upgrade your kernel, because if you don't upgrade your kernel and you turn off caching, your clients will crash. The kernel has some bugs and will just basically drive upload and crash the server if it's got to be constantly hitting the server for every operation. Don't use the no AC, no attribute caching option. You would think it would make sense. Turn on no attribute caching, but it actually also turns on synchronous I/O, which slows everything down. So you want to use some separate options. AC timeout equals 0. Turn off your negative lookup cache. All right, I'm so done with NFS. There's other bugs I didn't cover. Upgrade your kernel. All right, next problem, you used ext4 for big data, and now your data is corrupted, and you can't even run the file system checker because you run out of memory. So you use XFS or ZFS, but that's another talk. ext4 was written by some good people, but it was never meant for big data. XFS was written and maintained to deal with huge file systems. It's gonna, it's got another 5-10 years life left in it, so use XFS. All right, now we're gonna talk about Linux swap. You're running your application. You actually can run it now because you've got all your NFS bugs fixed. Now you've run out of memory. Linux is running so slowly. All right, so why does Linux handle swap so poorly? Well, because Linux doesn't lock the UI in memory. Other applications or other operating systems, rather, might lock the UI in memory. And more importantly, other operating systems enforce room in the page file for every byte in memory. And this is important. Linux does not do this. On Windows, if you've got 16 gigs of RAM, you have to have a 16 gig page file. If you don't have that, you can't allocate memory. That means that at any point, Windows can swap out everything in memory and replace it with everything on disk. If you've got an application that needs to be swapped out, it can do that immediately. Linux can't, because it's used both the RAM and the page file for all allocations. So Linux is going to have only a very small amount of RAM to swap things in and out, and it will never finish. I'm sure all of you have seen the Linux swapping bug. The reason that this doesn't work well is because nobody actually uses Linux swap. You just run with it disabled, just turn it off. So HPC, no swap. All right, so you actually do want to use swap. There are a few cases where swap makes some sense. And you're using it, and your application wasn't swapping heavily, but your system stopped working anyway. And you're using RAID 1. You didn't buy RAID cards in your service because you wanted to save some money. Don't do that, but you did. So Linux is going to crash because there's a bug. It does affect recent kernels. Upgrade your kernel and or use swap files instead of swap partitions. All right. Another issue, server's unresponsive because you're doing a lot of stuff in memory. Your application hasn't spent the time to become a database, so it's just allocating memory willy-nilly. And you have huge pages enabled in your kernel. All right. Transparent huge pages is this great idea that somebody had that just totally complicates the Linux kernel to no end. The Linux kernel for huge pages to work has to constantly be compacting and defragging memory to make enough room to be able to allocate these huge pages. It's 1999 again, except instead of double spacing and defragging our drives, Linux is defragging our memory. And obviously it's buggy. So just turn it off. Never into huge pages enabled, disables all the compaction logic, do huge pages in your application if it makes sense. Next problem, you're reading a huge file, you're thrashing disk constantly. But you've got tons of RAM. Linux should be caching this. The page cache exists to read all the data in, cache it, and you don't have to read disk anymore. Why isn't this happening? Well, it's because heavy writes are pushing, any writes, not even heavy writes are pushing the red data out of memory. The kernel doesn't care. Upgrades aren't going to help this issue because it's going to prioritize writes going to the cache over reads. So it's not going to try to cache your memory, your files. So you have to do the same tricks a database app uses. You've got to lock the memory into RAM, which you can do pretty easily, but you'd have to know to do it. All right, you did run out of space because your application actually works now. You've been reading and writing, you're having fun. Now you've run out of space. What do you delete? Running a disk usage report on a system, on a file system with hundreds of terabytes of data is going to take some time. It's going to take days, potentially. So cron a disk usage report, add locking, add file rotation so that you have the old files even if you ran out of space. All right. So lots of problems potentially with big data. You know, I haven't gone over the compute side. That's a whole other issue. Gone over the storage a little bit with you. I'm going to talk about the future of Linux storage very briefly. So like I said, by itself, Linux is not really a good big storage system. Linux does not have the tools you need to be able to do big storage well. So again, if you have the money, don't use Linux for big storage. Buy an enterprise storage system if you can. Enterprise storage systems will do things like be able to allocate every single disk individually, right? So Linux, if you've got a RAID card, it can't see every disk, it just sees what the RAID card gives it. Big storage systems, you can configure the amount of redundancy you have. So you can say, I want an entire node to be able to go offline, or I want, 5 disks to be able to go offline. You can configure how much overhead you have, a third storage overhead, 50% storage overhead. You can configure that overhead. If you want to use Linux, and you can, buy good block storage, which means a good RAID card and direct attached storage. Plug that into your server, fill it up with disks, you're good to go. In the future, there are some things, Btrfs maybe, there's Oracle's working on it. Ceph, Red Hat's working on that. ZFS on Linux perhaps, or just switch to BSD, but that's another talk. Ceph right now can provide good block storage. So the difference, really quick, between block storage and object storage. Block storage is just, the kernel sees it all as one big contiguous storage space, and it has to put a file system on top of that. Object storage, you're storing and retrieving objects, you're storing and retrieving files, so you've already got the file system there. Ceph right now can do block storage, and so to use that, you either have to be using some kind of virtualization system where it's expecting block storage because it's just assigning that to a VM, or you've got to put XFS on it. And nobody's going to support you. People are doing it, but nobody's going to support you if you put XFS on Ceph and then serve that over NFS. It might work if you spend a lot of time figuring it out, but nobody will support you. But Ceph is working on the object level storage as well. So Ceph has block storage down, and they're working on the object level storage in the form of the Ceph file system. Probably still 5 to 10 years out, but when this hits, it's going to be pretty nifty, because then Linux will have essentially an enterprise level storage system built into it. It'll be able to address each drive separately. It'll be able to configure the redundancy levels, the erasure coding, all that kind of stuff. So this is pretty nifty. When this finally gets going, then the enterprise storage people might be in some trouble. And of course, the Linux NFS in-kernel server needs to be put down, and it will be. There's a project called Ganesha NFS, which is ready now for some workloads. It's getting heavily worked by Red Hat, so this will be going again soon. And Gluster. So for now, if you want to do if you want to do big data storage on Linux, use Gluster. Gluster is really simple. What Gluster does is it takes your existing block level storage, your existing RAID cards and drives, you put XFS on it, and then the Gluster system, what that adds is it duplicates the data at the file level across multiple servers and file systems. It's really simple, and it works. Pretty simple concepts, it's stable. So to scale that out, to get better storage, you just have to buy better disks, better RAID cards, that kind of stuff. Okay, and then just shout out to Red Hat. They do a great job, so give them money. All right. So I told you, buy supported hardware, burn in your hardware so you find your memory errors before your application does, encrypt data, upgrade your BIOS, turn on your fans, upgrade your kernel, upgrade your Perl, YAPC Perl, use NFS wisely, apply the NFS tricks in the talk, don't use swap, use XFS, lower your caching tunables, wait for Ceph to become stable. And that's it. Thank you. For Hadoop makes some sense. It's more if you're, yeah. If you structure your application around an existing big data system like Hadoop or something like that, Cassandra, whatever, then great, fine. There's no problem with that. You've got to make sure that you're maintaining it properly, but other than that, it works fine. What you have to be aware of that is that you have to structure your application that way. You can't just take a bunch of tools that bioinformaticists have written and throw them onto a server and then change them to use Hadoop. That doesn't work. So in our case, we really have to just have big servers and a lot of data that can be accessed over the network, because we're just running simple Linux applications. Well, not simple. We're just running plain Linux applications against huge data sets. So it doesn't fit our applications.
So yeah. Previously, I've written HDFS out on Hadoop specifically just to have file storage
Yeah.
for a non-very Hadoop like processing stream. That's what I was talking about, HDFS by itself and how to hold it.
Yeah, that might work. Yeah.
Do you know how the other like BSDs compare to Linux and some of these others?
Well, I haven't used BSD extensively. People say BSD is better. Try it and tell me. So, yeah. All right, I'm getting told we're done, so come by and ask me for questions.